We choose this design because it is very simple and easy to find the material. The material that we use is cotton, bioball, sand and charcoal.
This is sand material what we use in experiment of the water filtration, which is we use the bioball, gravel, sand, charcoal and also cotton. We use bioball as first layer because it can provide surface area for beneficially bacteria, support biological filtration and also improve water flow. Second, we use gravel for second layer because this can prevent sand from being displaced when pouring water. Third, we use sand because sand put a layer of fine sand above the charcoal because sand help filter out smaller particles. Fourth layer, we use charcoal. This is because we put a layer of activate charcoal on top of the cotton. Charcoal helps remove odor, color and also impurities. Last but not least, we use cotton of last layer in the water filtration because this acts can filter fine particles and can produce clearer water. After put a layer of material, we start the filtration.
For the BAP pond, we see a significant improvement in water clarity, with the visual changing from yellowish to completely clear. Dissolved oxygen increased from 6.00 to 7.56, which is indicate healthier water suitable for aquatic life and reduce organic pollution. pH also moved slightly upward towards neutrally from 6.88 to 7.38, showing better water balance. Turbidity remained also unchanged, around 9.11, but visually the water improved, meaning the filter removed fine color and organic particle even if the turbidity numbers stay similar. Flow rate of 1.39 milliliters per second shows the filtration system is functioning smoothly. For the mosquito pond, we see improvement similar to the BAP sample. Dissolved oxygen of DO increased from 6.96 to 7.49, showing better aeration and reduction of contaminants. The pH improved significantly, rising from 6.89 to 7.51, showing the filter system stabilized the water closer to neutral. Turbidity remained the same at 32.7, but just like BAP, the visual clarity changed drastically from yellowish to clear, proving that although some suspended particles remain, color and fine solid were successfully removed. The flow rate of 1.19 milliliters per second indicates filtration efficiency is still smooth and stable. For the methylene blue sample, the filtration system performed extremely well. The water changed visual from dark blue to almost clear, showing excellent removal of dye molecule and chemical contaminants. pH increased dramatically from 5.02 to 7.36, correcting the acidity and restoring the water to a neutral level. This is a strong indicator that the filtration media effectively remove acidic compounds. Dissolved oxygen increased slightly from 7.24 to 7.92, confirming improved water quality. Turbidity remains stable at 5.75, but the huge improvement in visual clarity shows successful chemical and color removal. When compare our filter water to Kowe and mineral water, I can see that our filter perform quite well in terms of DO and pH. The DO levels in my samples are close to Kowe, which is 7.40 mg per liter, and only slightly lower than mineral water, which is 8.50 mg per liter. The pH value are also very similar, staying around the neutral range, just like Kowe, which is 7.29 and mineral water 7.44. However, the biggest difference appear in turbidity. My filter samples are still much cloudier and turbidity values far higher than Kowe's, which is 0.53 NTU and mineral water 0.23 NTU. This shows that while our filter water can improve oxygen and pH, it is not yet as effective in removal fine particles. In terms of flow rate, milliliter per form is reasonable but still slower than Kobe faster flow of 1.76 liters per second. From all three samples, the Mosque pond water showed the greatest improvement because both DO and pH increased, and the visual quality became much cleaner after filtration. When compared to commercial standard, our filter water showed good improvement in DO and pH, but the turbidity, especially for the Mosque pond sample, is still higher than what professional filter usually achieve. To improve the filter design, we could add thinner filtration layers, such as activate carbon or small sand particles, and increase the filtration content time to reduce turbidity more effectively.
In summary, this water filter provides significantly clearer water and enhanced palatability by addressing physical and some chemical contaminants. This DIY water filter also highly effective and low-cost system for improving water clarity by successfully removing large sediments, turbidity, and certain chemical compounds.